Welcome to Bonhill Geography. Today we'll be looking at feedback in the carbon cycle. Now in the carbon cycle, feedback loops play a crucial role in regulating Earth's climate. Positive feedback loops amplify changes. This leads to a self-reinforcing cycle that can accelerate climate change and move further from natural balance or dynamic equilibrium. Negative feedback loops, on the other hand, counteract these changes, helping to stabilise the system and maintain dynamic equilibrium. This is the state where a system is balanced, despite ongoing processes. Let's start with positive feedback loops. First, we have the melting of ice and the albedo effect. As global temperatures rise, ice and snow melt, revealing darker surfaces like land and ocean, as you can see in the video behind us. These darker surfaces have a lower albedo, meaning they absorb more solar radiation. This absorption leads to further warming and more ice melting. This creates a self-reinforcing cycle, whereas more seawater and land is exposed, more ice melts, releasing further carbon, and again, reinforcing this idea of our positive feedback loop. Next, we have permafrost thawing. Warming temperatures cause permafrost to thaw or melt. This releases stored carbon dioxide and methane into the atmosphere. These greenhouse gases enhance the greenhouse effect, leading to more warming and additional permafrost then melting, creating, again, a positive feedback loop. Higher temperatures can also increase evaporation of water, adding more water vapour to the atmosphere. Surprisingly, water vapour is a potent greenhouse gas, so its increase can also lead to further warming and more evaporation. Lastly, rising temperatures and prolonged droughts increase the frequency and intensity of forest fires. These fires release large amounts of CO2, which enhances the greenhouse effect and leads to more warming and hence more fires, and hence a positive feedback loop occurs. Let's now look at negative feedback. Higher CO2 levels can help to stimulate plant growth, as plants use CO2 for photosynthesis. Increased plant growth can also absorb more CO2 from the atmosphere, helping to mitigate the rise in atmospheric CO2 levels. Simple. Secondly, increased CO2 in the atmosphere can lead to the more carbonic acid formation, which enhances the weathering of rocks. This process helps to remove CO2 from the atmosphere and stores it in the form of bicarbonate ions in the ocean. Overall, this can help to reduce atmospheric CO2 levels, but it could make the oceans more acidic. Now, as we already know, oceans absorb CO2 from the atmosphere, especially in colder regions where CO2 is more soluble. This process helps to lower atmospheric CO2 levels, acting as a natural carbon sink. Again, this process of diffusion can make the oceans more acidic, decreasing the effectiveness of the biological ocean carbon sink. This is formation of calcium carbonate. For example, we can see in the background here that due to ocean acidity, increasing ocean temperatures and more, we have a massive deathbed of coral. Our last form of negative feedback is increased evaporation. This can lead to more cloud formation. Clouds help to reflect incoming solar radiation back into space. This reduces the amount of heat absorbed by the Earth's surface. We call this effect the albedo effect, as we previously mentioned in this video. These feedback loops illustrate the complex interactions within the carbon cycle and how they can either amplify or mitigate climate change. Understanding these processes is crucial for predicting and managing our planet's future. Do look at my wording there. Last year, or a few years ago, we did have a question particularly on to what extent is an understanding of feedback essential in mitigating climate change, or something of the sort. That was a 20-mark question. Thank you for watching Bonhill Geography. All of the answers to the 8 questions that you've just seen are found throughout the video itself. See you next time.